morning. The Legacy of Intellectuals, Resource Person, Dean by Ycet, HOD Computer Engineering Department, faculty members and participants. On the fourth day of Faculty Development Program on Artificial Intelligence, we welcome you all to the gathering. It is a matter of great happiness to welcome you all in the Faculty Development Program organized by the Department of Computer Engineering. Now, I would like to invite Dean Academic by Ycet, Engineer Dinesh Gupta for the welcome address.
Anshu ma'am, am I audible?
Yes, sir, audible.
Today's resource person, Mrs. R. Sathya, Engineer V.R. Burma, Chief Coordinator, Engineer Robin Kumar, HOD of CSC Department, colleagues and my dear participants. Good morning to all of you. I, Dinesh Gupta, Dean Academics of Jogananda College of Engineering and Technology, Jammu, feel honored and privileged to welcome you all. Today's resource person is Mrs. R. Sathya. She is working in SR.G College, Chennai, and has a rich experience of almost 20 years of experience in industry and 30 years in the education field. She has done her engineering from Madras University, MTech from Bangalore Institute of Technology, and she is pursuing PhD from Bangalore Institute of Technology, Chennai. She has completed more than 20 courses from Coursera and have 2 patents under her name. She has published so many articles in world-famous publications like Future with Quantum Computing, RFID applications for physical and information security. She is a permanent life member of CSI. She has organized more than 50 workshops, FDPs, and guest lectures. She has presented more than 50 research papers in national and international journals of repute and presented more than 50 papers in seminars and conferences. She has also attended more than 40 national and international workshops. She has also acted as a resource person in more than 40 events. And she is IIC ambassador and IIC coordinator of her college. We always uses so many services offered in our so many events, and she never said no to us. Thanks, Sathya ma'am, for accepting our invitation again. Madam Banakam.
Thank you very much, sir, for inviting me again for your college. I'm privileged to do.
Ma'am, Banakam.
Vanakkam, sir. Nice, vanakkam, sir.
I know Tamil kunjam.
Yeah, you told like you are from Chennai. It's nice to hear from you, sir.
That's why I know Tamil. Kunjam. Okay, ma'am. Thank you very much for accepting our invitation.
Thank you very
much, sir.
Thank you very much, sir. Now I would like to invite the resource person for 4th day of FDP is Mrs. R. Sathya to conduct the session on content-based image retrieval system for real images. Ma'am, please start your session.
Thank you, Ashish. And thank you for the honored welcome address. It is always an embarrassing moment, also a pleasure moment to get to know about our own profile on the stage, right? Thanks for the same for the entire Ycet team. And a warm welcome and great greetings to all the energetic and enthusiastic participants who are all actively joined over here. I think nearly 70 members are there. I hope my voice is audible, sir.
Yes, ma'am, you are audible.
Yeah. I am indeed very privileged to share my session today to the extent of your expectation. I think I will fulfill my session to reach your expectation level. Let us be more interactive and discuss now regarding CBIR real images. Shall we move on to the session, sir?
Yes, ma'am, you can start.
Yeah, I am very glad to thank Engineer Dinesh Gupta, sir. This is my 4th session for Ycet. And regarding IA, that is being an innovation ambassador, I have given 3 sessions for Ycet. And it is really a well-organized event. For each and every event, they just do a proper orientation. And as soon as the event is over, it is immediately uploaded in YouTube. and the entire team is working towards a well-organized event. I really appreciate you, sir. It's really a teamwork. I cannot stop appreciating you people, and keep rocking like this. I'll just share my session. Oh, is that okay? All the participants are ready to hear from me? Yeah, I hope all are faculty members. So let us not be like a student keeping mom and listening to our faculty. Let us be more interactive so that we will have some more energy to participate. Shall I go on? And first of all, let me get something from you. What may be content-based image retrieval? Some of you may be knowing, or some of you may be aware of that, heard about this word CBIR. What it is actually? Any idea? Anything? Any guesses on that? I think participants can unmute yourself and talk, right? Sir, is that enabled? Is a chat box is enabled, and also they can unmute? At least you put it in chat box. What may be a CBIR? Content-based image retrieval, as the expansion is like that. Any guesses at least? Say, for example, if I want to search something, what I do? Suppose if I want to search for this artificial intelligence overnight, we people are purely depending upon Google, right? Google search engine. We just live in that for the entire day. And suppose I want to search based on artificial intelligence, I just type the keyword, and I like assume that whatever content I am getting on the screen is purely based on artificial intelligence. I just rely on that. I get the information from that, right? Is all the informations are correct? Whatever I am getting, everything is promptly derived there. How do I get from Google whatever information related to artificial intelligence? Are during this pandemic period, we would have searched for many diseases, like how to get the how to know the symptoms, how to recover from that, what are the medicines I can take. Everything you just depend upon internet, right? And do you feel like everything is reliable and everything is real? Actually, why I have given it is for real images is I will be discussing about something about how do we find out what are the real images, and how do I get the object deduction methodologies, and I will just touch upon some recent techniques like YOLO and that, and even some digital nostalgics and that, right? Can anyone tell me what may be CBIR? Anything, even it is wrong also, no problem. We will not get punished for getting any wrong answers. Shall I get some answer from you? Yeah, I just to get something. No idea. Yeah, great. Okay, at least you try. As I told you, you just Google something and get the relevant informations, right? But here, I'll just move on to the topic. Yeah. My presentation will be like this. How do I retrieve some of the images, and what is the main difficulty behind getting the images what I am going to search for, and how do I represent the images, what are the recent trends in representing and retrieving the images, and how do I index it? We know very well that if I want to search among our students, some 60 members are there, I may call them randomly or in a sequential manner. Unless otherwise I have given in a roll number wise, it may be difficult for me to search for a particular student. In the similar way, I just put everything as a database set of images in a database. And whenever I need a particular image, I will be retrieving that based on the indexing. I just give some unique identity for that, or even you can give some notations for the images. We call it as a labeling of the images, and then you can just match with that images, right? As I have asked a question of CBIR, content-based image retrieval, instead of giving the text as a search, we will be giving the image as a search. That's what we are going to discuss today. And at last, I will be going as a practical session based on YOLO. What is it, YOLO? Any idea? What is the expansion of YOLO? What is the expansion of YOLO? I think you people have heard about that. What is that? YOLO game, right? YOLO toy. I'm not meaning that. Anything regarding this machine learning algorithm, YOLO? I need some answers. Even you can give some wrong answers also, no problem. YOLO? What is that? YOLO mean? You only look once. Okay, YOLO is nothing but you only look once. By just seeing the image itself, I can easily identify what are all the divisions available there, what are all the segments available in that. I will just discuss you on that at the end of the session. Is that okay? Can I cover all these topics now? I need some interactions. It will be very, very, very monotonous, I think. Are you all following me? Or it's a lunch time? Are you all taking lunch? Yes. Yeah. You only live once. Actually, in Google, if you search for YOLO, it will be coming like that. That's what I told in the beginning itself. Don't rely on Google. You only live once. Yeah, obviously, you only live once only. But here, regarding our machine learning, we mean YOLO means you only look once, not live once, look once. You just see the image and get the parts of the images as such, the segments of the images according to your requirement. Okay. And now, yeah, normally in traditional method, what we do is, if I want to search for a lily sort of images or some lotus or whatever I wanted to search, what I do is I will be putting the text as in Google lily or lotus or like that. And how do I get the required images over net is based on the annotations. Say, for example, if these lily flowers have been annotated with dog, even though I just, if I search for dog, I'll be getting this lily picture. Have you ever realized that? So don't relay that whatever Google is giving you the output, it is not the correct one. Suppose if being a developer or being an architect, being an designer, suppose if I had done some mistakes, that mistakes will be affected for the entire output, right? The same thing happens over here. Whenever you annotate with wrong annotations, wrong labeling, Google will never find out whether it is wrong or right. It will just match with that keyword alone. So even though I give lily, if I have labeled it as labeled a dog as a lily, it will give me dog as a lily. Are you getting my point? So you cannot purely confirm that, justify that whatever I am getting over Google is correct. And the text-based retrieval method, this is the normal problem with our text-based retrieval. And one more thing is also there. I am searching for lily, but what I get is along with the lily flower, I am getting some pond, some leaves, some water, isn't it? But I am not interested in that. I'm just interested only in the flowers, right? And you can just search along with its biological name. These are all the traditional method of text-based image search engine. And one more best example I can give is Apple. If I Google Apple, what I thought is I am affordable to buy an Apple iPhone. So I am searching in Google Apple, but it may be giving me a fruit, right? So if fruits are at the top relevance, okay, frequently searched item over Google, so immediately I will be getting Apple. Apple as a fruit picture only I'll be getting. I may not be getting the Apple iPhone or Apple iPad. Are you getting my point? So as a human, what is my intention is to search Apple iPhone, but Google doesn't understand what I realize, I feel, isn't it? But nowadays the scenario has been changed. This is a traditional method I'm telling you. So if I give Apple may be green apple, red apple, and Apple mobile or laptop, whatever I wanted to retrieve, right? This is a problem with our text-based image. It doesn't understand the semantic gap, the meaning. Apple, it does understand either it may be a fruit or like Apple brand, isn't it? And what are the limitations of the text-based approaches? Image annotation. Say, for example, as I told you, if I have only 60 members of the students, I can easily recognize them. But imagine that I have thousands of people to monitor. It is really, really difficult for me to recognize each and every person. That is a problem over here in image annotations. We cannot manually annotate each and every images. And human perceptions, what I have told you in the previous slide, Apple, human perception may differ. Even my perception towards this screen will be different from your own perception, right? If you are really, really new to that, all the keywords will be very, very new to you, right? And we need to satisfy all the customers, isn't it? That is the main scenario behind our search engines. Okay, even from the layman persons to the higher officials, they have to get the correct output from the search engines. And a deeper abstract is needed. Queries that cannot be described. I cannot give a detailed description about each and every searching process I wanted to do. I just visualize the images. I just put a keyword alone. Sometimes what happens, I will be in need of exact match. So what I can do is, let me take a text-based approach. This is a keyword I am going to search in Google. So what I can do is text plus, you can use the keyword special letter plus based approach. That means what happens is it will find you the exact match. If you use a plus special character, it will give you the exact match. But one scenario over there is it will be retrieving only from its own databases, that is its own relevant databases. You know very well, Google is not a single server maintained machine, right? So you may be having a distributed number of servers available there. So whatever link they have, it will be displayed on the screen. That's it. And normally, if I say Lily or Apple, whatever may be, how do I extract? How do I get the output on the screen? Say for example, when I say a ball, okay, cricket ball, what may be in your mind? What color may be the cricket ball? Okay, we will just relate with that color, shape, texture, isn't it? That size. The same thing happens over here. When I keyword, say cricket ball or tennis ball, so how do I get the pictures are based on the low level features. That means that what is a color, what is a texture, what is a shape, what is a size, what is a segmentation part. Based on those local features or low level features, I'm going to extract the images, right? So how do I get that RGB? You know very well, we will be having the combinations of red, green, and blue. And whenever you have an image, that image will be converted into grayscale. And again, it will be in terms of pixels. Normally, you will be using a 255 and a 255 matrix size. And each and every pixel will give you the concentric level of what color it may be. Say, for example, if I have a blue color ball, so here in the center, if I have a blue color ball and the remaining outer border may be blank, it may be only white. So wherever the concentrated pixels are available, I just get that relevant information, relevant number of a pixel amount alone, I'll be calculating that. That's what we do over here. From that, I can easily identify where that ball is residing. How do I recognize a ball? This is a local level features, or you call it as a low level features. And histogram. These are all some of the what to say attributes. Based on that, you are going to retrieve an image. Okay. And here, if I have an image, I will be drawing the corresponding histogram of that. What is an histogram is, you will be like giving the similarity matrix. Okay, based on that, you'll be just drawing a plot. And one more thing is also their color layout. You can give the entire picture in a digitized manner, then you segment it accordingly. You just make it into sub blocks, divide the entire image into small blocks, and then do concentrate on which part you would like to retrieve. Okay. And this is an most commonly used example for retrieving the images based on the color. So you just extract the color features and then compare with wherever, look at this. So the rest of the pixels are in some other colors, and you just find out where exactly you need to get it. And one more thing is also based on the shape also you can extract the features, right? These are all normal scenarios we will be using. And one more important thing is texture. What is the coarseness of the image? What is the contrast of the color? What is the regularity? And based on this texture also, you can extract the images by using the keywords. And the segmentation is very simple. You just divide that image into small segments, or you call it as a parts, and which region you really would like to focus on. And I never like the entire picture, right? So only a small portion of that I may be in need of that. If you really concentrate on a small amount of that, you may be getting high accuracy level. And based on your size of the image, you just extract it, not the entire image. It depends upon the purely depending upon the customer's requirement. Okay. And these are all the traditional way of representing an images, right? So what we have seen is, I'm just summarizing, recapping whatever we have discussed earlier. And I just refer the entire image as a pixel representation, and then either I can use tiles, or tiles we know, like for our floor building and all, we will be just placing the tiles, right? So the tile size may be depending upon our house measurement, the tiles may be different in size, right? And the regions, you just allot. Okay, how do you categorize your images? Say, for example, in a room, I may be in a house, I may be having a dining room, kitchen, bedroom, bathroom, and also how do I like split that? Okay, so it is purely based on the requirement. And low level features already we have seen: color, texture, and shape. Why I have given all these things are whether I am getting the accurate images, whatever I am extracting, whatever I am thinking in my mind. It's not the case always, right? So we are moving into a scenario called content-based image retrieval. Content-based image retrieval. Say we would have come across most of the students' paper define. Suppose if I give some word, even though they do not know the answer, they will just give blah 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 answers, right? That is content. They just wanted to fill up the content, right? But here what happens is visual similarity of the images has to be matched. Whatever I see on the screen, whatever I think in my mind, it should match. The human perspectives along with the system's output should match. That is the major constraint behind this content-based image retrieval. It is of retrieving the similar images from the given databases. You know very well, you have a database. From that only I'm going to extract. Don't think that I am just innovating something. It's not the case. Even though if it is not in the database, I insert some images according to my need, right? And why do we need CBIR? First of all, what is the purpose of CBIR? Are you following me? Can you tell me? Yeah, what is the purpose of CBIR? We know this quote, right? A picture is worth 1,000 words. Even if you give a session for the entire day, right, you may remember only some of the lines of that. But if you watch a movie, or if you just visualize something, you can remember for a lifetime, right? The same thing happens over here. Why do I key in a text for getting the images? Why don't I check with the images itself? Say, for example, I like one dress. Okay, instead of searching for the dress in so many shops, or so many e-commerce site, or asking all my friends how to buy it, where to buy it, what is the cost, you just imagine a scenario. You take a picture of the dress, immediately you will be getting in your mobile phone, isn't it? What is the methodology called as? Any idea? I don't want to waste my time. Have you ever come across that? I just wanted to buy some accessories or dress. I don't want to depend on others. I just tap it on my mobile, just click that the same picture, whatever I have gathered from it, I am going to get it. What is the application we are going to use for that? Yes, any idea? No, put it in chat box. I just like something and I have googled something. It is there, and as a picture it is there. I just wanted to buy it. How do I get it? Okay, let it be a question. Answer will be revealed after a few slides. Is that okay? Any answers in chat box? No? Don't go for lunch. By sharply we will complete it. Then you can go. You please listen here. You just answer me something. So, yeah. So CBIR, as I told you, yes, ma, something, is it machine learning? Yeah, machine learning, I need a specific application. We know very well machine learning is an ocean. I just need a specific application. How do I get what I want? What I want. I'll just give you the answer in a few minutes. And CBIR, text is a man's creation. Images are merely a replica of what man has seen. These are all, yeah. And the major constraint is visual similarity. Keep this word in your mind. Semantic similarity. You must get what you need, not what the system provides you. Keep that in mind. You always focus on your target, not whatever is getting as an output, right? And some of the real world requirements of this CBIRS performance, obviously, we need to increase the speed and reduce the time complexity, space complexity, and semantic learning. And we live in the world of images. We just forward so many images, whether we understand that or not, we simply keep forwarding to our friends. It is unnecessary also, but we don't bother about it, right? And concurrent usage, heterogeneity of the messages, and system evaluation, these are all some of the real world requirements, but we have to focus on these things. We have to design a system in such a way that our efficiency should be extremely utilized, extremely high. Yeah, this is the answer for what I have given you. What is this? Have you ever seen this picture? Have you ever seen this picture? What is this? Search what you see. That's what I told you. If I like some dress, if I like some accessories, I just click on that. I get it. I get the details about that. Then I can buy online or offline, whatever I do. Search what you say. What is this, ma? Any guesses on this? Anything? Yes. Google Lens. Yeah, exactly. It's Google Lens. Very good. What is it Google Lens mean? Have you ever used Google Lens? I think all our kids are using during this pandemic period. Whenever teachers are giving the homework, whenever they see some pictures, whenever they want to go to a restaurant, just they click on that and they will be getting the things what they need. And look at that. Just, yeah. These are all some of the applications of your Google Lens. If you haven't installed it, you just try to install Google app on your mobile. You can try these things. I hope all of you would have already installed it. And you can just translate. It is an image, but you can easily copy that image into a text, right? And even you can have the translators. In any language, you can translate if you don't understand the language what they have posted. And as I told you, you can just buy the accessories whatever you like. Just take a picture of it. Even you can try now also. You just install Google Lens and click on a picture whatever you are seeing, whatever you are liking, and you will be getting the relevant information regarding that. And whenever you go for ticket booking, you can just get that. And even we people have become very lazy. Even for saving the contact number of my friends and all, you just get that contact details and convert that into your Google Lens and add the contacts to your mobile. So almost everything they have done, right? But our motivation is what we can do beyond them. Okay, Google will never reveal the algorithms what they have used. So at least we have to go into that level and fine tune our work. What else I can do? Everything has come. But again, within a nanosecond, we are developing so many applications. What else I can do? And this is what Google Lens will do. If you want, you can take a picture of it. Google Lens is an AI-powered technology, as you told, machine learning. Actually, I just have a doubt. What is the difference between AI and machine learning? Is both are same? In earlier cases, we were using only artificial intelligence. What is that artificial intelligence? We are making the system to learn something, right? Artificial intelligence. We just make the system as an intelligent one, but we are not transferring our brain to that. We just transfer the input from our side to the system. And later, machine learning It learns by itself. Say, for example, by 1 o'clock, this session is over means automatically by 1 o'clock, it has to be shut down, something like that. So I just trained the machine in such a way that it does the task of a machine. We don't want to waste our time on small things. So machine learning is a subset of AI. Keep that in mind. Machine learning is a subset of AI, right? And as I told you, this Google Lens is purely used for scanning the images, translation, shopping. Yeah, good. Yeah, ML is subset of AI. Good, great. Yeah. So yeah, this is what I wanted to say. In the previous slides, I told you, like, if you want to search something, key in a text here. This is a normal Google search engine we do, right? But as I told you, you just give image as an input. How do I do? Can you Google it and tell me? In Google, suppose if I want to search artificial intelligence, I'll be typing the word, right? But I want to put a picture into the Google and I want to search. How do I do? How do I do? Yeah, I have got some answers in there. Not Google Lens. Yeah, Google Lens is also one of the answer. Good, good. Google Lens is also one of the answer. Any other possibilities are there to search a picture? You just give input as a picture and output also as a picture. Yeah. Any other answers? Any other answers I can expect? And here I have given the answer actually here. Look at this properly. Keenly observe. Google images. This is a plain Google I have given. Look at this Google images. You can use reverse search engine, Google's reverse search engine, or you put Google images at the top. Shall I? Yeah, 1 second. I'll just show you on my. Yeah, normal. I hope my screen is visible. Yes. I just Google.com. Yeah, this is a normal text, right? Suppose if I want to give Google images, just give Google images search. And here you will be getting images.google.com, isn't it? Are you following me? Are you following it? Yeah,
Yes,
Google
ma'am.
images we can upload. Yeah, good, great. So you can directly upload whatever images you want to search. Look at this icon over here. You can just either capture via photo or you can just get it from the gallery, right? This is one of the Google reverse search engine. And I'll just get back into my slide again. Yeah. So this is one of the applications of Google along with our Google Lens. And look at this. There are some other applications also by which you can input image and get input as an image, get output as an image. Okay, Google reverse search engine. This is the Chrome which I have shown you now. And one more thing I told you, like a Google Lens. And apart from that, you can use Google search on desktop browsers itself, right? You can just install it. And Bing, Yandex and all earlier days, they have come across with inputting image as a query and getting result as an image. Okay, Bing Yandex, you can even search with that. You just take a screenshot of it and later whenever you are free, you try with that. And TinyEye. TinyEye is earlier cases we were using that. And you know very well, before 3 years, I think 3 to 4 years, Google Lens, that actual glass they have marketed, but it was become failure. Then only they have deployed this Google Lens and all. By the time TinyEye, this small SEO tools were come into existence. Okay, this is SEO means what is that? Search engine optimization. We always need the best result of searching, right? So search engine optimization. These are all some of the tools we were using for finding the images to get the relevant images. Okay. And you can try with all these things. And why do we need, why I am just shouting for these image search engines and all? Say, for example, I have given some amount of time to draw a sketch, but somebody has stolen that. You can easily get it, the source of that image, where who has actually uploaded that. So you can just give for the copyright violations, and you can find the similar images. You can find the dimensions and the metadata of the images, and you can just, as I told you, Google Lens, it is pulling the text and translating that. And you can just give credit to whatever images you have uploaded. These are all some of the usages of image search engines, or we call it as reverse image search. In normal image search, key in a text, get the image. Reverse search, key in a image, get the image. And now, what is a query? Yeah, an image already you have. You may be having from camera or from the gallery, or you have stored everything in a Google Photos. Okay, and it may be a rough sketch, or you may give a symbolic description about what you want exactly. Right? These are all some of the queries you are going to feed to the systems. And CBIR, as I told you, content-based image retrieval. In other ways, it is called as QBIC, query by image content. The another name for CBIR is query by image content. Image content. As I told you, you can search the images with the help of low-level features such as color, texture, shape, and all. So look at that. I am just giving a color, and whatever color I have given is blue and yellow. So based on these two combinations, the images from that will be extracted. Okay, image, whatever is relevant with that colors, blue and yellow, the pictures will be represented. And search by shape, you can just have the shape. Maybe you may be having a short picture, or you may be having a flight. It doesn't understand whether I am searching for a short or whether I am getting going to get the display as shark or flight. But it doesn't mind it. It will just extract only the shape. Okay, and query by sketch. In query by sketch, I just drawn some outline of that. I will be retrieving the informations based on that, right? Yeah. Okay, I have given you some introduction about the image retrieval. How hard it is? Is that very easy? What we have given only theoretical part. Is that much easy? Is that much easy? Can you tell me the difficulties behind that? Yeah, tell me why image retrieval is very hard. Tell me, can you answer? Can you answer? Shall I answer for that? Yeah. And look at that. I have given some picture. And what I need to search for, either I am searching for a sun, or I am searching for a water, or I am searching for a boat. Go that side. Okay. So I have to make it clear in such a way that the machine will not get confusion of retrieving the images, but still it will give you all the locations, right? And what are the right keywords to index this image? Okay, this is a picture I have given, right? And this is the problem with this. So whoever is annotating, suppose if you have they have given only the boat. If I am searching for sun, only this picture will not be displayed, right? But even though it is having sun picture, that is the scenario behind image retrieval. So you need to annotate the entire image with like sun, water, boat, right? And what is the word I am going to use to retrieve these kind of images? These are all some of the constraints in a place where we are going to design a project for image retrieval. And this is a semantic gap. One more thing is also there, semantic gap. What is it? Semantic gap mean? Already I told you the meaning will be different. Say for example, even though I have specified it as an apple, I never eat a green apple. I always used to prefer a red apple. So even though the fruits are same, what I need, I have to extract that. Okay, we need to fine tune that. And in case of content-based image retrieval, you mainly focus on reducing the semantic gap. You cannot get 100% result. We always focus on mirroring the accuracy level, right? And automate the image annotations, maybe based on the color, as I told you, cricket ball. Okay, so maybe in which color it may be, and you just put it on the edges, texture, layout, okay, shape relevant informations. Okay, content-based image retrieval and visual analysis of the content. As I told you, this is another name for QBIC, query by example. Already I have explained you, no need to go ahead with that. This is the exact scenario happening whenever I input an image, all the features will be extracted, I'll be getting the relevant images. But the problem over here is I may not be getting the exact image what I need. Look at this, boat is over here, but I am getting something like this. This is a problem with our normal scenarios. Only if you extract based on the color, shape, segmentation, you will never get the similar images on the screen. That is our research objective. What I have to add is, I have to add on the high level features also along with low level features to get the exact images what I need. Are you getting this point clearly? What we do is we will be just finding the nearby, you will be just getting the nearby relevances, then you will find the similarity between the images. Okay, and yeah, you just find the symmetric matrix based on that. Yeah, look at this image. I just wanted to tell you, here a tiger picture is there, right? But I just focus on tiger picture, but along with that I have grass, sky and that. So how do I make that abstract region in this manner? You take all the objects over the picture and you just make the regions accordingly. Then the tiger is at the center of the place. I just focus on tiger picture alone. I don't want these extra regions. I just close that. This is what we are going to do in our image retrieval. I'll just give you an example at the later stage. And you convert your colored image into grayscale images and you train it accordingly. You just recognize each and every faces of the persons. You train it accordingly. And this is the problem with our low level features. As I told you, it may be concentrated on color, shape, texture and all, but we concentrate on semantic meaning of that. You have to gather the informations accordingly. As I told you, along with the low level features, add on the annotations also, add on the semantics informations also, so that you may be getting the relevant image, whatever you are request. Okay, and this is a combination of all what we have thought. And searching by, once again I just yeah, so tiger, and I'm just querying by the keyword, or you can give the image as well, or you can give the sketch, or you can give the context of that. Now I just summarize whatever we have discussed now. Develop object recognizes for the common object. We just wanted to focus on the object deduction. We will just give you a session on that. Yeah, what is this actually? What is this all about? Can you tell me? Yeah, Ma, what is this actually? Even you would have played this game, right? What is this? What is this actually? What is this? Yeah, what is this picture about? Playing a rock, rock, paper, and scissor game, right? But as a human, I know very well what I give the sign, right? Whether it is a stone, paper, scissor, something like that. Based on my directions, I can play, right? But I have to train the computer, isn't it? Wait, some noise is there. One second. So I have to train the machine in such a manner that it will understand what game I am playing, right? And this is a traditional programming languages. I set some rules and feed the data, get the answers. But what exactly our machine learning will do is, I provide the answers, I give the data, then I am framing the rules. It is something like based on the feedback, again, I am feeding the answers, giving the data, getting the rules back. Okay, this is the exact scenario behind our ML. X-ray is not actually artificial intelligence unless otherwise you incorporate that into any one of the applications. You just make some recognition from that, some decision making based on that. Then
And last time tried to conclude by saying that जितने अखबार की स्याही का सूख पाती है, जितने में अखबार की स्याही सूख पाती है,
I'm not getting it.
खबर आ जाए.
Excuse me. No, and gestures, but it's a game. That's what I just wanted to tell you, that how we are training the machine to make that as a hand gesture. Based on the hand gestures, how do I play a game? Okay. Google Images we can upload, even from Google Photos. I'm just answering for the chat boxes. Google Images we can upload, even you can use Google Photos. You just tap on that photo, you can find out on which date you have taken, and wherever you went, it is something like a Google timeline. You can just check on. Okay. And again, you just train the model and predict your output, right? And have you ever seen this? So this is also one of the part of your AI. Even you can just get the pictures of your grandparents or whoever has expired. You can just make them laugh. Have you ever tried with this? Deep nostalgia. Have you ever tried that? Even you have an app, you can just upload the picture of whoever is not there, is not alive. You can just upload their picture and make them smile like this. This is also one of the basics of your artificial intelligence. But here the problem is how they pose, how they like, what is the position of that. Based on that, the smile, that gesture will be varying. Okay, you just try with that. Just for fun, I'm just giving you that you can just try with that. Then, yeah, these things, I just skip that. Do we people may be thinking like computer vision and image recognition both are same, but it is not the case. Vision means you just have like image classifications and object deduction, segmentations, image coloring and that. But recognition, make the decisions accordingly. You say, for example, based on that image, what I can process, what I can forward. Okay, take decisions, interpret the images, interpret our relevant images. Just make some decisions over the images, whatever you have gathered. These are some of the stages of our IP. I just wanted to show you. Yeah. Can you guess what is this? Can you guess what is this? Can you guess? whenever you are riding on the road, a traffic police will be there, and he will be like calling the persons whoever is not having the relevant documents and whoever is not following the traffic rules, right? But in future we never need of the traffic control and all, so automatically the system will detect. And even in Chennai MIT campus, they have installed this YOLO concept. You only look once. Whenever students are riding in 3 members per vehicle, they'll be getting fined automatically. Okay. So here, look at that. What is happening actually? This is a real-time object deduction. Real-time object deduction, and it is. Can you tell me what may be the methodology they are using? Just look at the pictures carefully. Look at the pictures carefully. What is happening there? They are splitting that into small regions, and each and everything. They are not capturing only the human, whatever, whoever is riding on the road. They are capturing all the objects on the roadside. This is the beauty of your YOLA. And earlier they have started with YOLA version 1. Now we are in YOLA version 3, and beta version is now 5. But I will just show you how to implement that as simple logic. Yeah. Classification. Yeah. It's, you can just get all the details, whoever is riding on the road. So in future, you may be avoiding this CCTV and all. You can install YOLO concept. Okay. You only look once. It is purely for real-time object deduction. And you may be asking me, suppose if the person is riding on the bike and he may be sitting straight, or he may be like bending his body on the bike itself, right? So how does it recognize it is a human? That's what this is a very beautiful concept behind YOLA. Even though the pose changes, even though the person is like moving from one place to another place, it will easily recognize them. Okay. And there is no pooling layers in our YOLO concept. It can detect multiple objects. I mean that this is the region I have given. In that, it can easily identify this is a girl and this is a chair, this is a window size, something. Each and everything it will predict. Okay, and identify the locations also. I mean to identify only the cars, but it is also identifying it is a car. You can ask me, how can I train like that, ma'am? I will show you a demo for that. Look at that. This is a TEDx speaker. He was speaking, and all our audiences. It is they are just focusing the camera on the audience. It is exactly predicting who are all the person sitting there and what are all the objects they are holding on their hands. Everything it is capturing. Yeah. Shall I give you a practical session? Are you all ready? I'll just give you a demo on how to implement this YOLA. Then we can complete the session. Is that okay? Shall I move on? Yes. Shall I? It's a small thing only. I'll just show you. And you can practice. It will be very much interesting. You just don't take it for serious matter. You just make it as a hobby of developing small apps, small applications. Okay, by force you don't do that. You just install label MG. Can you do parallelly along with me? Yeah. Can you? If you have system, you can just do it parallelly. And even I will share the website on your chat box also. Just to put it in your chat box. You just install label MG. This is the tool where we are going to install our YOLA concept, a small project we are going to do now. Okay. And according to your operating systems, whether you are using Linux or Windows, you just go to Windows version 1.8. This is the recent version they have introduced. So I'm just installing that. Right? Are you all following me? Are you? So you just, it is a zip file, just extract it. And this is a exe file, you just execute that. Yes. Yeah. And now I hope you would have gathered some images on your system. Let me take, I am having some, wait. Yeah, I have some images on my downloads. So let me take, I have some Solo V3 for, I have some images. Okay. What you do is you just create a folder wherever you like. Just to create a folder and you just give the folder name as YOLO V3. It is up to you. You can give any name, no problem. But I have given the code like that. So you just give a directory. Under that, I have some images like this. Say, for example, I have some leaves and some designers. Okay, these are all some images for demo I have given. Okay, you just have some 5 to 6 images for training our model, right? And now just go to the label. I have run that label link, label mng. Yeah, this is the new file. You just create. Are you following me? Label mg. I have opened that. Okay, and now just go to open directory. I don't want to save it. This is the previous thing I have done. I just unsave that. Okay. Okay. Now where I have saved my images are under YOLO V3. Are you following me? You just have some set of pictures, save it in a folder and select that folder. Boys, can you keep that? Can you go that side? Session is going on. Okay. So I just have an image. I have taken that image. Okay. Open the drive. Open the drive. Okay, this is a folder. Okay. Now what you can do is, I'll just maximize the screen of it. Look at the whatever images I have saved in that corresponding folder, it will be displayed. Look at this. This is the first image, this second image, what I have shown you now. All the images are displayed over here. And now I just wanted to label it and I just wanted to train that. Okay. And now you may be having two concepts over here, Pascal or YOLO. Since we are going to use YOLO, you just click on that and capture that region. This is what YOLO we do. You can just have the leaves as green or only the like white spaces, or if you have flowers, you just label that as a flower. Okay, you just give it as green or leaves. Just make the label as leaves. Okay, and I'm storing it. I just take one more picture and click on this, create rectangular box, and again I'm labeling this as leaves. Likewise, wherever I find leaves, I just give them as leaves picture. Okay, just make it as a box, and again it is already there. They are reducing our typing time, right? Already it is there, so I'm just clicking on OK itself. That's it. Only 3 items I have stored it. Now you just save everything. Okay, that's it. And what happens is, when you go to the directory where you have saved YOLO V3, I have given image 1, right? You can just look into, yeah. So I have given some images and I have loaded only images. But look at that, some of the text information also has been added over here. Let me take for image 2. Image 1, I'll take image 1, right? Okay, yeah, this is for image 4, right? So for image 4, one corresponding text note has been created. Let me open that and tell you what is that actually. Oh, it's not there. Okay, this is a HTML file for the corresponding image. Yeah, look at that. Whenever you are saving there, automatically what happens is the corresponding text file for that image will be done. And here, this is nothing but this is class. I have given leaves. So whatever labels I have provided, suppose if leaves are given for 10 times, for all those 10 files, 22 will be there. This is a labeling number. And here, this is your x-axis, where exactly that region is occupying. This is y-axis. This is the height and weight of that. It is something like when you give an image. What is that image? Yeah. Let me take. I am choosing this region. So this x-axis and then x and y-axis here. What is the height and what is the weight of that image? From that, I can easily find out which region it occupies. Okay, that is what we are providing the information. So automatically, it is taking. Since I am selecting the region here, automatically it is gathering the information and putting it as a text file. Likewise, for all the images, the corresponding text file will be added. Is this clear for all of you? Is it clear? Shall I move on to the next one? This part is over. I have chosen some images and I have labeled it. I have given the region for that. That's it. Now, we will just give a free open source online directory like a collaborative learning, right? We just open Colab. Have you ever worked with Colab? At least you just try today. If you haven't tried it, something is there in chat box. Yeah, good. It's good if you have worked with the Colab. Now, just go to Colab. And here, before getting into the Colab, what you do is, once again, you have given some images, right? Make all the images. Actually, these are all necessary messages, but even I am just adding it for demo. I'm just giving that. Okay, you just make all the images as a zip file. Okay, already I have done to show you as a demo. I just remove that, and now you just make all the images and all the classes, whatever you have done, everything. Okay, almost everything. Okay, you just add all the images along with their text into a zip file. Just add. Okay, and now just make it as images. Okay, since I haven't renamed it, it is already giving me as YOLO because the folder name is YOLO v3, but I want to change that as images. It is according to your wish. You can just give your favorite name as a file name and image name, right? And here I assume that all the images and the corresponding configuration files in the form of text has been zipped. And now just go to Google and go to your own drive. Okay, wherever you want to work, just upload your folder. YOLO v3 folder is there now. I have already uploaded to show you as a demo. You just go to that and I'll remove that and show you again. I'll just show you. So you just upload the folder. YOLO v3, just upload it. Yeah, just upload it. And you no need to upload all the images because I have given only the extraction of that, right? You just remove everything. You no need to. You just create a folder alone and upload your zip file called images. That is enough. Okay, you no need to do everything. Just create a folder YOLO v3 under your Google Drive and upload the zipped image file. Right now, and one more thing, I have coded with Python. We just upload that notebook. Okay, I'll show you that here. Now, you just upload. Now I am going to run some Python code for training our model, right? And here, just go to downloads, and I have a Python code, train YOLO v3. I'll just show you that code over here. Upload it here. Is that clear? How do you do it? Yeah. Just 2 to 3 minutes, I'll complete it. Yeah, this is what we have got it. All your Python code has been incorporated over here. And you just go to settings, notebook settings, and make this GPU as available. Hardware accelerator, either it may be a GPU or TPU, just make it as GPU and save it. And now you just execute that, make NVIDIA GPU enabled for you, just run that. You will be getting, it has been enabled. What is the size of the GPU you are going to use? Everything will be displayed over here. Just it will take some time to run on. Yeah, look at that. Here it shows that this is the MB I am going to use, and now I am not like occupying that much memory space. Otherwise, you can be able to see that the usage of the memory. Okay, this is my initial stage, so I haven't given any usages there. And you just run all these files. Okay, you just yeah, you connect to Google Drive. It will be asking you the permissions to access your drive. Just give that permission and allow, right? And then you just use this .NET data set and synchronize with that. Okay, it has been executed. You are just getting that, and just clone with the .NET. Just execute it, each and everything like that. I'll just share you that file to your WhatsApp group itself if you need. Okay, just run it. And you are going to configure this YOLO v3 and all the, like, whatever files you have, you just train them, that image files. Extract the images from the databases. Okay, and at last, it will take some time to execute. So look at this. This is a zip file I have uploaded, right? I'm just taking that from my drive. YOLO v3 is a folder name, images.zip. I'm just uploading here and going to check whether the images are available or not. Okay, and start the training. Here I haven't run this. It is taking some time. So you just practice from your system. You will be retrieving the leaves I have given, right? So wherever it finds the leaves, it will be displayed on the screen over here, right? Yeah. So yeah, you just get, it is something like that. You will be getting the images. Say, for example, if I'm just checking for cola, you will be getting that corresponding region on your screen. This is a sample I am just showing you. Since it is taking much time, it's taking, yeah, I have to change the settings and all. No issues. You just try. I will just share you with WhatsApp. Okay, and I'll just move on to my session. This is simple example you can carry on. You practice from a simple one. I'll just share my screen again. Yeah. So these are all some of the examples, data set you can go on. These are the projects existing under CBIR. And these journals are purely for your pattern recognition or image processing. You can just submit for your publications. Okay. And thank you all. This is my contact. If you have any queries, you can contact me. And I would like to thank the engineer Dinesh Gupta sir for this FDP, 5 days FDP. And I thank all the participants who were listening. Yeah, I will share the content seriously. I'll share it today itself. Yeah, thank you. Yeah, thank you all.
Thank you very much, ma'am, for such a beautiful and lovely talk. We gained a lot of knowledge and enjoyed the presentation. I hope all the participants get benefited from this presentation. Once again, thank you so much, ma'am.
Thank you.
Now, I would like to invite Engineer Robin Kumar, HOD Computer Engineering, Ycet, for the formal vote of thanks.
Thank you, Anshu ma'am. I'm audible.
Yes, sir, you are audible.
I feel honored and privileged to extend the vote of thanks. Firstly, I'd like to thank Mrs. R. Sathya for such a fruitful session. Thank you so much, ma'am, for your valuable time. Now, I would like to thank Dinesh Gupta, sir, Dean Academics, YCT. So, thank you so much, sir. You provide such a platform for us to conduct such kind of FDP. Now, I would like to thank B.R. Verma, sir, Chief Coordinator, YCT. Now, I would like to thank all the participants and the members who have joined the FDP. Thank you so much. Thank you all. Thank you again, Satya ma'am, for such a wonderful presentation.
Thank you so much, sir. Thank you all. Take care. Thanks, Ashish ma'am.